Okay, hello. It's a great pleasure to be here. Of course, I'd like to talk to you about chill beams and the technology in general. The whole part started in the late 80s, where the oil prices was very, very high, and using water for heating, it was very, very common. With these high oil prices, it made it also affordable to use it for the cooling application. So that was the main driver, saving cost. We're using water as a cooling medium, and then we have as another benefit is low maintenance and space savings. So with these 3 points, it was the starting point for a good 90 year, for the good 90s to make the chill beam technology moving forward. Okay, chill beams using chilled water for cooling. Why is it not so much in the residential areas yet? Inside is the fear of condensation. But there are condensation sensors available. You still have a centralized ventilation unit there to push the fresh air into the room, but with the circulation inside the room, which one brings fresh air into the space. But it's called induction, will happen with the nozzles, and with the induction we're introducing secondary room air through a water coil and mixing that one with the fresh air and blowing it into the room. The chilled water is typically 1 degree above room dew point to avoid condensation, which one is the biggest fear in this design of doing so. There is sensors available to avoid condensation, so it's not more a big issue in that sense around it. But water is 4 times more efficient to cool down than air, and with that one it makes it so nice and affordable. It saves you also a lot of space inside the ceiling. It is so much more quiet. There's no noise inside the room, so which is the main point to go ahead with this solution. Actually, you can summarize them to all as one part together. The key advantages are sustainability, which one is now topic all over the place, so saving energy, make it affordable, comfort in the space, so the people which will live in the space are very, very comfortable, and then space efficiency. So all these parts is very, very important. For a hotel, there comes the additional part towards it, the comfort of the guest inside. In office buildings, people moving around, comfort is of course also important, but the customer experience in a hotel room, if it's a very nice climate and the even temperature of the room is priceless. Yes, it is correct. On the unit, on the chill beam itself, there's no fan, but there is still an AHU at the back of the system to provide fresh air. After that one, we put silencers on it to make the fan noise almost disappear. The nozzles are also in a way formed that is reducing the noise which the unit would create. So with this part, with very low fresh air, which one is the minimum requirement, the design of the nozzles basically creating no noise. So it's very, very quiet.
妥思在全球多个标志性的建筑当中成功地应用了冷量系统，您能否分享几个比较典型的案例，具体的介绍一下冷量在这些项目当中的应用表现？
There are many, many projects around it, and I feel very proud about the projects which I have done in Southeast Asia, which a majority is office buildings. Getting these designs inside, getting the feedback, it is very, very quiet. The people feel comfortable. That is the biggest reward what we can get from those projects. We do also a lot of testing towards this project. Every building is unique. There's no standard solution towards it. And we're testing for each and every building the designs to make sure what the end customer gets fits what the designer have predicted. So that's the key point towards it. In Europe, there are some hospitals done and also a hotel done with chill beams. These 2 hospital patient rooms and hotel rooms are very, very similar. To a certain extent, the patient room is actually more difficult compared to a hotel room. Then there's a sick person lying in that room, freezing, shivering much easier than when you be a well-healthy person in a hotel room comes in. So having them comfortable helps them to faster to recover from the illness, which is a great result out of it. And getting this one into the hotels is also the next step.